Okay, let's get into a demonstration around how TrueFort can stop ransomware. This is Fortress. This is our platform. This is our realm view. This gives us visibility into the applications in the environment that TrueFort is protecting. We can see in this application, this is our e-commerce application. We can see our behavior analytics is running here as we can see a real-time view of the connectivity to the e-commerce application. If I go a little deeper into the e-commerce application, I can see what makes up the roles of the e-commerce application. So we can see a web server, we can see a SQL server, we can see a Mongo database server in that application. We can also see the connectivity to those workloads supporting the e-commerce application. So we can see connected workloads on the left. This is an NTP server, another web server. And on the right, we can see unregistered nodes in the environment. So these are nodes that we're unaware of that are not in our behavior profile. So we build a behavior profile to support this application. And you can see the lines here on the left and right are green and orange. Green means that that behavior profile is allowing that connection. That connection is in the behavior profile. It's a normal connection, access to that server. On the left, we also see an orange line. This is something that's an anomaly. It's something that we've identified that's outside our baseline, our behavior profile for that workload, for the application. And we're showing it in orange as it's an anomaly. We're alerting on it. So we're going to let you know that, hey, this is trying to access the server, and we're going to show it to you in an orange line and alert on it. And that's the connectivity we see in Realm. So the visibility that we support, a very deep contextual information that we're showing here around the application and what supports it. So let me go in and let's show how we're building the profile within the application itself to support microsegmentation, to support other metrics in that environment. So again, we have the e-commerce application here. We have the roles that make up the e-commerce application. So we have a web server, a SQL server, and a MongoDB. So if I click on the web server, we can see through the tabs here, we have general information, we have RBAC information around the teams that have access to it. We have the different agents that are a part of the web server application. So this could be as simple as one agent to tens of thousands agents under this role for the web server. Then we have our profile. So our profile, we come in here and compile our behavior analytics against the metrics that we want to create a profile against. One of the differentiators with TrueFort is we're not just a microsegmentation company. We support many different metrics on a server that we can run a profile against, including CPU, file, memory, network, software that's installed on the machine, process, who information around identity and network. So I can come in here and I can compile, I can run our behavior analytics against many different. So once I've done that compile, I can select the different time and date ranges. Once I've done that compile, as you can see, I've already run a few compiles here. If I go to the rules, this is the output of the network compile. So you can see, I can see incoming, outgoing, listening information about the network ports, protocols, source, destination IPs that have been seen within our compile. So I can make changes to this, I can keep it, but I can push that policy out into the OSs, in this case, the web server, as a microsegmentation policy and in a native format of that firewall. So for instance, if we're using the TrueFort agent, the SentinelOne or the CrowdStrike, I can push that down to those agents and it'll apply it to the native firewall windows or IP tables. So I've done this for the network. I've run a profile and a package for the software that's installed on those machines, around the processes that are running on those machines, for instance, and the identities that are accessing those machines. So whether they're non-human identities like service accounts or human identities, I can run a profile of who accesses the environment. So very important in ransomware and also in zero-day attacks is understanding service accounts that have been compromised or service account context on access to those servers. We can look at that compile and take action against it. So for instance, if I go back to the network, we also have rule packs here. So these are our workflows to take action when we see an anomaly in the environment. So for instance, if I go into the network, I have an action to block an IP. So if I see an IP that we haven't seen before, I can block it and so forth. And I have other workloads in here also around the software that's installed, processes that are running, FIM, file scans, and identity. So I can take action by basic alerting, or I can take action where I log a user out, kill a process, and so forth. So that's what we've done here. So we've ran this profile. We've secured the servers in our environment, against ransomware attacks. So let's do a little test here. And I want to show you if I go into an existing server here. So this is a server that has been compromised by a ransomware gang or a bad actor of some sort. They've come into this server. They're going to try. Normally what bad actors do is run a script that's going to scan the environment and try to encrypt files, try to gain access to those servers where a TrueFort agent is not. So let's set the stage here. This is our server where we have some important files on it for this user, very important finance and so forth. If we look at the services that are running, there is no TrueFort agent or CrowdStrike or SentinelOne agent running on here in this environment. So it's essentially open to ransomware. And if I go to another server here, for instance, this server here, we can see that this is protected. We have our Bushido agent, which is our TrueFort agent running on the machine. We have some files here. So let's go back. I'm going to go back to my attack machine. So I'm going to pretend I'm the bad actor. I'm going to run my script in the environment here. And so it's attempting to breach the servers that I just showed you. So we're starting to get some information. We're starting PS exec. So very basic ransomware type techniques here that they're using in a Windows environment to gain access to these unprotected servers. So as this runs, it's going to take a minute or two, and I can go back to the initial server that we have. Oh, you can see, look, what's happened here. So we can see that those files, those important files that I had on my machine are now encrypted. And if I come up here, we can see that they've put in a warning as a backdrop that all my files have been encrypted. They want us to send Bitcoin to the criminal organization to get the decrypting key so that we can get our files back. And they've also put a little note stating the same thing, right? So this is bad, right? Our files are encrypted. We don't have access. I think everyone listening to this understands how devastating ransomware attacks can be for businesses. We've seen businesses go to the extreme of replacing all their computers because they've been ransomware. And so if I come back here and we look at that web server and we look at the alerts that we've generated, so if I go back to the web server, we can see where we're protected. Our files are fine. Nothing happened. So nothing in the background. We haven't had any change. We're business as usual on a server that's protected, in this case, by the TrueFort agent. And we can see the alerts that we've generated here. So we've seen here that, hey, there was a TCP connection that normally is not allowed. And if I go into that alert, we can see that, 10.32.85, which was the IP of the bad machine, attempted to connect to this. We haven't never seen that IP connect before. So what we did is a workflow within the rule pack, and we've denied that connection. So we've done a real-time block. So you can see within a second when we received the alert at .24 that the real-time block was put in place at .25. So that's one way that we can protect servers against ransomware. For instance, if it was a server that had access to the environment, we would be able to control that access in another way. So for instance, we could see the process that's running in the environment. So we can see that they tried to run that process to ransomware, but it did not work because it's not allowed to, and so forth. And we can also see on the other server, the SQL server, where we tried to attack the SQL server, the same things happened. So we're generating alerts and we're taking action to protect the environment in real time. And if I go back to the attacking server, you can see that, I couldn't access certain machines and so forth. So it failed. So the net of this is running a TrueFort agent in the environment to protect against ransomware, as I showed you, is an excellent way to protect the other servers, other workloads in your environment from ransomware attack. Thanks very much.